Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 25. The question is, a right pyramid of square base and height capital H has uniform charge distributed everywhere within its volume. So this is your right pyramid. And this has a charge which is uniformly distributed throughout its volume. It means at each and every point the charge density is same in this pyramid. Modulus of electric field and potential at the apex P of the pyramid are E0 and V0. Because of this charge distribution in this right pyramid, the potential and electric field intensity at P is V0 and E0 respectively. A symmetrical portion of height small h from the apex has been removed. This portion has been cut and removed. So now the question asking is modulus of electric field and potential at the apex P of this truncated pyramid. Because of the remaining portion of the pyramid, what will be the electric field intensity and potential at P? So let us solve this question. First important thing, you should know what is right pyramid. So right pyramid is basically a pyramid in which when you draw a perpendicular from apex P on its base, it will pass through the center of the base. And that line, that perpendicular line itself is called the axis of the right pyramid. That is one thing. Now, what is the volume of the right pyramid? The volume of the right pyramid is the volume of cuboid divided by 3, means 1/3 of the cuboid. And that cuboid is basically with the side this and height h. So means if this is the cuboid, this is the right pyramid with side A, B and H. Its volume will be the volume of cuboid with the base A into B and height h divided by 3. In our case, A and B we have assumed as small a. So this will become your A square into H by capital H by 3. And this has been derived here. If you see, this has been derived here. In this pyramid, we have assumed, because no charge has been mentioned about, so we have assumed that Q, capital Q was the total charge on it, and rho was the density, charge density in this pyramid. And E0 and V0 initially with the full pyramid is given. Now the part which has been removed is this. Since this is a square pyramid, means a square right pyramid, means if any portion of the pyramid is cut keeping the surface parallel to the base of it, the new pyramid base will also be a square. So this is the part which has been cut and removed. So we have assumed that this side is A prime. Since it is a square, so this side will also be A prime. Small h is the height given in the question. So accordingly, we can derive the volume V prime of this as A prime square into h by 3. Now from the symmetry, if you see this pyramid and entire this pyramid, the ratio of its height, small h by capital H, will be equal to the ratio of its side, A prime by A. This one is A prime, this one is A. So this is what we have written here. Further, from the dimensional analysis, we know that at P, electric field will be, as has been given in the question, E naught will be proportional to the total charge on this pyramid, that is Q by capital H square. And E field at P, when the pyramid is the portion of pyramid which has been curved, because of that the E field at P will be ET will also be proportional to, now the charge on this is Q prime. We have written here Q prime and rho will be the same because charge density throughout the volume of the original pyramid was same. So here also the charge density will be the same. Similarly, V naught will be, as we know, will be directly proportional to Q and inversely proportional to I. And Vt will be Q prime directly proportional and inversely proportional to small h. So this has been written over here. So if we take the ratio of Et by E naught and putting all the value and using the previous equations in the last page, that is all the equations over here. So you will be getting Et by E naught as small h by capital H. So Et will be small h by capital H into E naught. Similarly, Vt by V naught will be getting equal to small h square divided by capital H square. So Vt will be h square by capital H square into V naught. For this portion of the pyramid which is left over, we have assumed E prime and V prime is the electric field intensity and potential respectively. One thing to notice here, because of symmetry, the electric field due to the entire pyramid, that is E naught, that is E naught E naught will be in this direction, and for this portion which has been removed, EP will also be in the same direction. So if we subtract EP, from E naught, we will be getting the electric field intensity due to this pyramid, the portion of the pyramid which has been remaining or which is remaining there. So using that E prime, we can write E naught minus ET. So E naught minus, we will be putting the value of ET from here, and we will get this equation. So this will be one of your answers. Similarly, for V prime, V naught minus VT. VT you can put from here, you will be getting this. So this will be your answer. So important to understand about the E field, because E field is a vector quantity. Potential is a scalar quantity. So potential can be added or subtracted algebraically. But E field, since being a vector, it cannot be added uh, algebraically unless or until it is in the same direction. So E naught is also in this direction. EP is also in this direction. Same direction. So we can write comfortably E prime is equal to E naught minus So hopefully you understood the entire concept of solving it. In case any doubt, you can write in the comment box. I will definitely come back for the clarification. Thank you.